Welcome back to another online lesson here. So today we're going to be covering 10.2 areas of trapezoids, rhombuses, and kites. So we're going to start off with what a trapezoid is. Okay, a trapezoid is a polygon with 4 sides, but only 2 of those 4 sides are parallel to each other. The area of the trapezoid is found by adding together what we call the bases, multiplying that by the height, divided by 2. So if you look at this picture right here, this is a trapezoid. This line, this side here, be parallel to this side here. So these 2 sides are parallel to each other, but these 2 sides are not parallel to each other, a trapezoid. So one of these, the 2 sides that are parallel are called the bases. So you take one base and you add it with the other base. You multiply it by the height. The height must come down again vertically to the bases. The height must be vertical to the bases. You divide the height by 2 or you multiply it by 1/2, which is the same as divide it by 2. So sometimes you might see this equation written like this, where your height is divided by 2 times b1 plus b2. But either way, these are the same thing. So let's go ahead and give it a try on our first word problem here. So we've got a situation with Nevada. If you've ever looked at Nevada, the state of Nevada is actually a trapezoid, where this side is parallel to this side, but this side up here is not parallel to this side down here. So this is a trapezoid. So the area is going to be found by taking your height, dividing it by 2, multiplying that to your 2 bases added together. So if we look at our statements here, one of our bases is 205 miles. The other base is 511 miles. And the height must come again perpendicular to the bases. So this distance right here, which would also equal this distance up here, is 309 miles. So our height is equal to 309 miles. So if we plug all of these into our equation, we get that the area is going to equal the height of 309 divided by 2 times my base 1, which is 205, plus my base 2, which is 511. Don't close that parenthesis too soon like I just did there. And then we can take out our calculator. See if I can get that calculator a little bit more visible on the screen. There we go. So we take out our calculator and we are going to take 309, divide that by 2, multiply that by 205 plus 511, enter, and you get the area of 110,622 square miles. So we have 110,622 square miles. And that would be the area of Nevada. So we have another trapezoid here where we could find the area of it. Let's find the area of trapezoid PQRS. Area of trapezoid PQRS. Now, you'll see on this one that we have a 30, 60, 90 triangle. So when you're looking at this trapezoid here, we have our base and we have our second base. We have base 1, we have base 2. These are parallel to each other. So we have our equation that area equals the height divided by 2 times base 1 plus base 2, But what we do not have is our height over here. We don't know what this distance is. But we do know that this is a 60-degree triangle. So if we took this off, we have this right here, where this is 60 degrees, this is a right angle, and we're looking for this height right there. If you remember, on a 30, 60, 90 triangle, we need to know what this distance is. Well, if this distance is 5, this right here, this distance right here would also be 5. From here to here has to be 5. So this distance right here has to equal 2. And now if you recall on your 30, 60, 90 triangle rule, or you could also use sine or cosine or tangent. This would be tangent. So I could say that the tangent of 60 degrees is equal to the opposite divided by the adjacent. The opposite is the height, the adjacent is 2. I could solve this by multiplying by 2, and that would be your height. Now again, you could take out your calculator and you could figure out what 2 times the tangent of 60 degrees is, which is 3.464. Now, if you don't want to go that route, and if you do remember your 30, 60, 90 rules, you could use the 30, 60, 90 rule. If you recall on the 30, 60, 90 triangle, the short side, okay, is the side that we always base everything on. The long side is the short side times the square root of 3 times the square root of 3. So you have 2, you have short side, this is square root of 3 times the short side, which would be the same exact thing. Oops, you didn't see any of that there. You'll notice on my calculator here that 2 times the tangent of 60 is 3.464, but also is 2 times the square root of 3. 3.464. So you can either use your 30, 60, 90 triangle rule, or you can use SOHCAHTOA, which in this case it'd be just specifically tangent. So our height can be either equal to 2 tangent of 60, or it can be equal to 2 times the square root of 3. So that's our height. And then we already know what our bases are. So we go back over to our area equation, and we say that the area is equal to, you could say 2 times the square root of 3 divided by 2. Base 1 plus base 2 is 5 plus 7. This 2 and that 2 divide away, leaving just the square root of 3. 5 plus 7 is 12. So the answer, as an exact answer, is 12 times the square root of 3. If you take 12 times the square root of 3 on your calculator, you could round it. So 12 times the square root of 3 on your calculator is 20. You could round that to the nearest tenth. Call that 20.8. So the area is about 20.8 rounded. And that would be in meters squared. So back to it. Big idea on this one. We're going back to our right triangle rules. Because it is a 60-degree triangle, we can use our 30, 60, 90 triangle, which if this is the short side, because this is 60, then this is going to be the square root of 3 times the short side, and the hypotenuse is 2 times the short side. Everything's based upon that short side, and that's an S. Okay, your 30, 60, 90 triangle rule, or you can use SOHCAHTOA, in this case specifically tangent. Flip it over to the next page. And we've got what is called a rhombus, but can also be called a kite. We have a rhombus, we have a kite. A rhombus is a square that does not have 90-degree corners, or really what a square is where all the sides are equal. So in this case, we have something where all the sides are equal, but the corners do not meet at a 90-degree angle. That's called a rhombus. A kite is similar to a rhombus, but only 2 pairs of the sides are equal. So this side equals this side over here equals this side over here. But regardless, whether it's a rhombus or whether it's a kite, this is the equation that you use to find the area of both a rhombus and a kite. You'll recognize, though, that we have some letters here we haven't used yet. D. D stands for the diagonal. Okay? The D is the diagonal. The diagonal literally goes from one corner all the way over to the other corner. One corner all the way over to the other corner. So we have to figure out our diagonals to be able to find out the area. So you take both diagonals, you multiply them to each other, and then you divide by 2. So let's try one here. So if this distance is 2, and this distance is 5, we could say that diagonal 1 is equal to 7. The distance from K all the way to M, K to M, which if we call K to M diagonal 1, we could call it 7. And then we could say L to N, which we could also call diagonal 2, would be equal to this distance of 3 added with this distance of 3, which is 6. So the area is going to be 1/2 diagonal 1, which is 7, times diagonal 2, which is 6. And then all you got to do is take out your calculator and take 1/2 times 7 times 6, 21. 1/2 times 7 times 6, 21. So the area of that one would be 21 meters squared. Last but not least, I'm sure you guys have seen this shape right here on the roads before. It's called the HOV line, and that's kind of hard to show up. Hopefully you have it in front of you as well. But there's some numbers written here. We have, in this case, a rhombus. All the sides are equal. Okay, and they say that this side right here is 6.5. This comes through and this comes through, and these are a 90. And this distance down here is 2.5. But again, we have a 90-degree triangle. So we have a triangle here where this is 2.5 and this is 6.5. But it's a right triangle. So how can I find that distance on a right triangle? Well, I can use Pythagorean theorem. I can say that x squared plus 2.5 squared is going to equal 6.5 squared. 2.5 squared is, well, it is 6.25. 6.5 squared is 42.25. Subtract 6.25. get that x squared equals 36, which is nice. And then I can take the square root. Technically speaking, it's plus and minus, but since we're talking about a distance, we're only going to use the positive. So we know that this distance is 6. If this is 6, then this is 6. If this is 2.5, this is 2.5. So we have everything we need to be able to find out our diagonals. So diagonal 1 is going to be 12. Diagonal 2 is going to equal 5. So the area is going to equal 1/2 times 5 times 12. Half of 12 is 6. 6 times 5 is 30. So that would be and that's in feet squared. So the area of the rhombus diamonds that you find on the HOV lanes, according to this, is equal to 30 feet squared. So that is how you find the area of a rhombus, of a kite, and of a trapezoid. So again, this is going to be, well, obviously up on YouTube. Go ahead, follow through with these notes, and then spend the time that you need working on the Math Excel assignment on Math Excel. Hopefully you guys are finding these helpful. If you need anything, please reach out to me. I'd love to help you if you guys need anything more. Hope everyone's staying safe, and I'll talk to you soon. Thanks. Bye.